So in this question, we have some graphs. So let's do our Oyxirga first. Oyxirga. The origins are all at 0. The y-axes are all acceleration. X-axes are all time. The intercepts, that's varied, so we can't really answer that. But we want to look at that for each individual graph. We can read acceleration time. The slope is delta A over delta T, which is the jerk. And the area A times delta T is going to be the change in velocity. So we want to know what happens. Oh, so now we'll read the question. There's a tennis ball that's dropped from the top of a tall building. Air resistance cannot be neglected, so it matters. So we drop this ball, and we can think about two different quantities that relate in this case. We've got our acceleration and our velocity. Well, we know that air resistance is going to have an effect, but the instant it's dropped, the acceleration is minus 10. The velocity is 0. We know the velocity is going to increase, but we know the acceleration is going to decrease. It's going to decrease and come to some value. Eventually, if it were dropping far enough, it would end up at 0. So the acceleration might end up at 0 at some point in time. So the key point, though, is at time 0, the acceleration is a big number. So it's not passing through the origin. So we look at choice A, and we see it's at 0, 0. At time 0, the acceleration is 0, and that's just simply not true. If we look at choice B, we see a positive value. At A, we see a positive value. And at D, we see a positive value. So just looking at the y-intercepts, what they could tell us, B, C, and D are in. But we know, since air resistance matters, the acceleration is going to decrease. So that takes out choice C. And so when we look at choices B and D, they both ultimately end up at an acceleration of 0 at about time t. The question is more about, the distinction that we have with them is more about how they're getting there. So in choice B, we show that the acceleration changes rapidly, and then the change gets smaller and smaller until eventually it's barely changing at all when it reaches its constant velocity, constant acceleration of 0. In the D case, we see that the rate is increasing. So in other words, in choice B, we have a gentle reaching of acceleration of 0. And at D, we have our greatest change, or our harshest change, right at the instant the acceleration equals 0. And we may remember we did a graph that showed the percentage of time, and that is that it is a gentle reaching of acceleration. It gradually makes a change. Because as the object goes faster and faster, the air resistance is proportional to the velocity squared. So as the velocity increases, the force of air resistance increases. But as it goes faster, the acceleration decreases. So the rate of change of velocity decreases, which means the rate of change of force decreases. And the rate of change of force decreasing means the rate of change of acceleration decreases. So in this case, the jerk, the rate of change of acceleration is decreasing. The slope is decreasing to 0, and that's why we have choice B.